So here we have questions on chemical bonding, and we'll walk through the questions together. Question 1. Use the following portion of the periodic table to answer this question. Which letter represents an element that participates in covalent rather than ionic bonding? In order to predict the kind of bond that would form between two elements, we consider the difference in their electronegativity. So elements that are on the far sides of the periodic table, for instance Y, J and Q, compared with W, M and Z, they have very large electronegativity difference between them. Okay, so because of that, if the difference is very large, you're going to get an ionic bond. But if the difference is relatively smaller, you're going to get a covalent bond. So the only one here that can form a covalent bond is X, because X is somewhere in the middle. So the difference in electronegativity between X and the other elements would be smaller compared to when you pick from the extreme ends. So the answer here is B. That would more likely give you a covalent bond. Okay, question 2. A balanced chemical equation is based on the law of. Let's write a balanced equation and explore the principle behind that. Okay, so if we have, for instance, the Haber process, when nitrogen reacts with hydrogen to give ammonia. So, oh no, that looks, let's take a thinner ink. Okay, all right, I think we're good now. Okay, so if we have nitrogen gas reacting with hydrogen gas, this is a gas and this is a gas, and this gives you, in a reversible reaction, this gives you ammonia gas. If we are to balance these equations, what we do is, the principle behind that is we want the atoms on both sides to be equal for each of the elements. Okay, so for instance, nitrogen has 2 atoms here, as indicated by the subscript 2 we see here. But on the right hand side, nitrogen is only 1 atom here. So what we do is we put a coefficient 2 here, such that when you multiply 2 by the number of atoms of nitrogen here, you're going to get 2. So 2 times 1 here would give you 2 atoms of nitrogen. But then the atoms of hydrogen on the right hand side is now 2 times 3, which is 6. But on the left hand side we only have 2, so we put a multiple of 3 here, such that 3 times 2 would give you 6. Now this is balance. So what this tells us is that the number of atoms we started with should be equal to the number of atoms we end with after the equation. And the law that states that is the law of conservation of matter, where it tells us that matter cannot be created nor destroyed, although it can be transformed from one form to another. So if a reaction takes place, although the form of the matter changes, when the amount of matter is considered, what we had at the beginning would be equal to what we have after the reaction. So the correct answer here would be C, conservation of matter. Okay, question 3. A coordinate covalent bond could be formed between. A quick review of what a coordinate covalent bond is. It's a type of bond, a type of covalent bond that is formed between 2 species where the bonding pair of electron comes from only one of the 2 of them. So although they come to share a pair of electron, but then that pair of electron comes from only one, while the other just gets bonded and shares that pair of electron from the other party. So let's look at what that looks like exactly. So we'll draw the Lewis structure for the molecules we have here and find out which one would give us a dative bonding or a coordinate covalent. It's also called dative bonding. Okay, so hydrogen here, notice it's an ion plus, and that tells us that hydrogen has lost 1 electron. So hydrogen in its ground state has 1 electron, so it loses that 1 electron and then has an empty shell. So it will just look like this. Now if we want to bond that with boron chloride, boron trichloride, So boron will be the middle element here, and boron is in group 3 of the periodic table, which means it has 3 electrons outside. So when you're writing the Lewis structure, you only indicate the valence electrons outside here. So it has 3 valence electrons. Now 3 chlorine atoms can bond with the unpaired electrons to become paired. So you have a chlorine atom here, a chlorine atom here, and a chlorine atom here. Notice that all the electrons here are now bonded. We don't have any lone pair of electron, any electron pair that is not bonded to anything. So this and this would not give you a coordinate covalent bond because there's no lone pair of electrons to be shared. So this is wrong. But then if we have boron chloride here, let's just repeat that. Okay, boron trichloride with ammonia. So ammonia has nitrogen in the middle here, and nitrogen belongs to group 5. So you have 5 valence electrons, 1 2 3, and then 1 2 3 4, and then 5. Let's put the pair of electron at the top here. Okay, so you have 3 hydrogen atoms. They would bond with the unpaired electron. So you have 1 2 and 3 hydrogen atoms here. We notice that nitrogen or ammonia here has a lone pair of electron that is not bonded to anything. So this lone pair of electron can be shared with boron trichloride because boron trichloride has no unpaired electron here. So when boron trichloride bonds with ammonia, they share this pair of electron. So this would most likely give us a dative bond. So we have actually found our answer. But let's see why the other ones are wrong. So we already have the Lewis structure for ammonia here. So we draw the Lewis structure for phosphorus trichloride. Phosphorus, let's see, phosphorus belongs to group 5. So it would have 5 electrons here, 1 2 3 4 and 5. Now the 3 chlorine atoms would go with the unpaired electrons here. So you see phosphorus trichloride has a lone pair, but it cannot bond with ammonia because they both have lone pairs. So both of them are givers, they are donors, but for them to form a bond we have to have one donor and one receiver. So since they are both donors of lone pairs of electrons, they can't form a bond between each other. So C is wrong. Now D, where you have boron trichloride here, this one, and then aluminium trichloride. So let's see what aluminium trichloride looks like. Aluminium belongs to group 3, so 1 2 and 3. Then the chlorine atoms will go with the unpaired electrons here. Now notice aluminium trichloride has no lone pair of electron. Also, boron trichloride has no lone pair of electrons, so they are both receivers. They are supposed to receive the pair of electron. So both of them cannot form a dative bond because neither of them have lone pairs of electrons. So the correct answer is C. Oh, B. It's B. All right, question 4. A metal M forms 2 types of chlorides, MCl2 and MCl3. Which of the following laws best explains the relationship between the chlorides? Okay, so let's see, we have MCl2 and MCl3. Let's write that out. So MCl2 and MCl3. So here, one atom of the element M is bonding with 2 atoms of chlorine. This should be 2. So the ratio is 1:2. On this hand, we have 1 atom of element M with 3 atoms of chlorine. So although M and chlorine are the ones bonding, we can have different formulas for them if you vary their number of atoms. So you have multiple ratios here. And the law that describes that is the law of multiple proportion, where when you have 2 or more atoms coming, or 2 or more elements coming together, if their masses or their amounts are varied, you're going to have multiple ratios of those elements coming together to give you different kinds of compounds. Another very common example is carbon monoxide and carbon dioxide here. So the ratio of carbon to oxygen is 1:1, while here it is 1:2. So they are both the same elements coming together, but you're getting multiple ratios of their combination. So the law that best describes that is the law of multiple proportion. So the correct answer is D. So question 5. A solid substance with high melting and boiling point is likely to be So when we study the properties of the compounds that are formed from the various bonds, they have very unique properties. Now, those with very high melting and boiling point tells us that the bond between the individual atoms or molecules are very, very strong. So it takes a lot of lattice energy to break the bond between them. So that's a very unique property of ionic compounds or electrovalent compounds, because the bond between the atoms in electrovalent compound is an electrostatic force of attraction between the positive and negative ions that are formed. So that's a very strong bond. Covalent compounds, on the other hand, although the covalent bond between the atoms is strong, but covalent compounds, when you apply heat to them, it's the molecules that are separated, not the atoms themselves. So what that looks like is, let's see if we can figure out a visual representation for that. If we have water molecule, okay, so water is OH2, okay, and you have another water molecule here, you have another water molecule here. Now when you see water, what we see there is actually a bond between the molecules of the water. So this molecule of water is attached to this one by an intermolecular force here called hydrogen bonding. Now here also, the O here is bonded to this, okay. So although between the H and the O in the same molecule we have a covalent bond, but between one molecule to another we have an intermolecular force there. So the intermolecular force is actually weaker compared to the covalent bond. But once heat is added to a covalent compound, what breaks is actually the intermolecular bond. So because that bond is weak, it's easy to break. So you don't need a lot of heat energy for that. And that's why they generally have low melting and boiling points. Okay, so that's why the answer is not covalent compounds. A non-metal generally exists as a gas. So the molecules of that element are in gaseous form, which means that the molecules are free to move around. So they are not very bonded to each other. So it's easy to break the bond between them. A dative covalent bond is a type of covalent bond, and that also would have a low melting and boiling point. So the correct answer here is an electrovalent compound. Okay, and that is C. Question 6. A solid substance with, so the same question. A solid substance with high melting and boiling points is likely to be A or An. So compounds with high melting and boiling points are compounds that have very strong bond between them. And so compounds that correspond to that properties are ionic compounds or electrovalent compounds. So here the answer is A. So the electrostatic force of attraction between the ions is very, very strong. So it takes a lot of lattice energy to break the bond between them. So the answer is A. Let's see question 7. All pure samples of the same chemical compounds contain the same elements in the same proportion by mass is a statement of, okay, so this statement is in accordance with the law of constant or definite proportion. What this means is, if you get a pure sample of a compound, it's going to contain the same elements regardless of where it comes from, regardless of what the source is. It will contain the same element in the same ratio. So for instance, water has ratio of hydrogen to oxygen in water is 2:1. This is the formula for water, right? So 2:1. Regardless of where you get the source of water from, could be rainwater, well water, tap water, distilled water, whichever, as long as it is pure, the elements contained there would always be hydrogen and oxygen in the ratio 2:1. So that's what the law of definite proportion or constant proportion explains to us. So the answer is C. Okay, here we go. Question 8. An element X forms the following oxides. Okay, the phenomenon illustrates the law of, right? So we have 3 oxides here. So X and O forms 3 types of oxides. We have X2O, okay, we have XO, then we also have XO2. Notice that it's the same elements combining. X and O are combining together, but they are combining in different ratios. So here we see 2 atoms of X and 1 atom of oxygen. Here we see 1 atom of X and 1 atom of oxygen. Here we see 1 atom of X and 2 atoms of oxygen. So the law that describes this phenomenon is the law of multiple proportion, that tells us that when two elements come together to form different compounds, if the masses of the elements are varied or the amounts are varied, you're going to get multiple proportions or multiple ratios of different compounds. Okay, so the answer here is A, multiple proportions. Okay, question 9. An element Z has a combining power of 3. Which of the following formula is correct of its compound? Okay, so in this instance, Z is combining with different elements to form the following compound. So let's see which is correct. The first we have here is Z3Cl2. Okay, so we don't know what element Z represents, but we know the combining power of Z is 3. So if this is Z and the combining power is 3, and chlorine has a combining power of -1, naturally, the combining power is 1 actually, the oxidation number is -1, right? Telling us that it's the anion here. So naturally, this would be the cation. Okay, so if they combine together, what happens is they exchange combining powers. This way, you just have like an exchange happening here. So 1 here goes to Z and 3 goes to chlorine. So you're going to have ZCl3. Okay, so that is not the case in option A, so that's wrong. Now, how about when it combines with oxygen? Remember, the combining power of Z is 3 and oxygen is 2. The combining power of oxygen is 2. When you cross that, you're going to have Z2O3. Okay, seems we have found our answer. We found our answer, but let's see the other ones. When Z combines with a sulfate ion, this is an example of a polyatomic ion or a radical. Now, it naturally has a combining power of 2, while Z has a combining power of 3. So once you cross this, you're going to have Z2, then 3 goes to SO3. So you put SO3 in a bracket, then put the combining power at the end here. So you're going to have this, which is not what we have here. Now, but what if you have zinc, the sulfide of that element, where Z combines with sulfur? So Z has a combining power of 3. Sulfur mostly has a combining power of 2. Okay, so when it combines, you're going to have the 2 goes with D, so you're going to have Z2S3, which is not what we have here. So the correct answer we have here is B. So we'll go with B. Okay, question 10. At ordinary temperature, water is a liquid, while hydrogen sulfide is a gas. This is because water has... Okay, so let's understand the question first before we look for what the answer is. So here we're told that water is a liquid at room temperature, but hydrogen sulfide is a gas. The difference between them is that the bond between their molecules, if you compare water to hydrogen sulfide, a liquid has... the bond between a liquid is still stronger than that of a gas. And that's why the gaseous molecules are able to move around, while liquid, there's still fluidity, there's movement, but it's still restricted compared to that of a gaseous substance. So it means that the bond in water is stronger than the bond in hydrogen sulfide. So which of these options would describe that? Strong hydrogen bonds holding its molecule together. I think we found our answer. So the hydrogen bond in water molecules is actually relatively strong compared to the intermolecular force in hydrogen sulfide. So the answer here is A. B says weak intermolecular force. If the force is weak, then water would not be a liquid at room temperature. It would be gaseous at room temperature. Here says induced dipole forces between its molecules. Now, induced dipole is a type of intermolecular force that is weak. It's a Van der Waals force and it's weaker than hydrogen bonding. So if this was the case, water would not be a liquid at room temperature. Then ionic forces between its molecules. Although ionic forces are very strong, but in water we don't have ionic forces because it's not an ionic compound, it's a covalent compound. So the correct answer is A. Alright. Question 11. Calcium chloride is an ionic compound. Which of the following statements accounts for its ionic character? So let's see. Calcium has high ionization energy. This is not true because calcium is a reactive metal, and reactive metals easily lose their electrons when they form compounds. So because there's ease to remove the valence electron, it means that the ionization energy is low, because it doesn't take a lot of energy to remove their outermost electrons. Okay, but non-metals on the other end of the periodic table, they have high ionization energy because across the periodic table, the number of protons and electrons are increasing, and so the attraction between the protons and electrons are very strong. So it's more difficult as you progress across, it's more difficult to knock out electrons that are on the outermost shell, and that means that the ionization energy is very high as you go across. So calcium has a low ionization energy. So Roman figure 1 is wrong, but 2 is right. And then 4 is also right because chlorine is a non-metal, and then it has high ionization energy, and that's why it would rather accept electron than lose electron, because it takes a lot of energy to remove the 7 electrons it has outside. So we found that 2 and 4 are correct. Now how about 3? Chlorine has high electron affinity. Electron affinity is the amount of energy that is released when an atom gains electron to form a negative ion. So chlorine is a reactive halogen or non-metal because it easily gains electron and releases a lot of energy in that process. So 3 is correct. So it means the correct ones here are 2, 3, and 4, and that's option A. So the correct answer is A. 12. Consider the following electronegative values. Which of the elements represented by the letters W to Z combine with hydrogen to form a purely covalent compound? Okay, so here we have the electronegative value of hydrogen to be 2.1, and then these are those for the other elements. A purely covalent compound is formed as the difference in electronegativity approaches 0. The closer the value is to 0, the more pure or purer the purer the covalent compound formed is, or the covalent bond formed is. So what we do is we check the differences between hydrogen and each of these elements here, which one will give us a value closer to 0 or closest to 0. So the answer is Y, because 2.1 minus 2.1 is 0, and that's the closest you get to 0. So H and Y will give you a pure covalent compound. All the other ones will give you a value higher than 0, and so it won't be as pure as getting 0 as the difference. So the answer here is Y, and that's D. Question 13. Electrostatic force of attraction between sodium ion and halide ion is greatest in... Okay, so halide ion is from halogens, group 7 elements. So here we see that sodium combines with different halogens, and the strength of the force of attraction between them depends on how large the electronegative value is. The larger the difference in the electronegative value, the stronger the force of attraction between them. In looking at the trend of halogens, what we find is that the electronegative value decreases as you go down. So fluorine has a higher electronegative value compared to the rest of the halogens. And so because the value of fluorine is very high, when it combines with nitrogen, you get a stronger ionic compound there. So the answer is sodium fluoride, because fluorine is very, very reactive and has a very high electronegative value. So the difference in the values between sodium and fluorine will be highest compared to the other halides. So the answer is C. Question 14. Electrovalent compounds are characterized by... Okay, so the properties of electrovalent compounds: strong reducing ability. So this is not true because... Oh, strong oxidizing ability, sorry. Oxidizing agents are mostly covalent compounds. Okay, so for instance, nitrates, halogens, those ones are usually covalent compounds, and so covalent compounds are good oxidizing agents. So A is wrong. Now, high melting point. High melting point is correct because the force of attraction between the ions in an electrovalent compound is very high. So it takes a lot of heat energy to break the bond between the ions, and that's why they have high melting point. Solubility in ethanol is wrong because ethanol is not a polar compound, and electrovalent compounds can only dissolve in polar compounds or polar solvents. So C is wrong. And then D, high molar mass. Covalent compounds tend to form high molar mass compounds because they form giant molecules. They form heavier molecules when they combine. So D is wrong. So the correct answer is B. Question 15. Electrovalent compounds normally, so let's see, have low boiling point. That's not true because the bond between electrovalent compounds, the ions in electrovalent compounds are very strong, so they will have high boiling point. Dissolve in polar solvents. Okay, so the reason why electrovalent compounds are able to dissolve in polar solvents is because the electrovalent compounds have charged ions, and polar solvents have partially charged ends in them, such that if you dissolve an ionic compound or an electrovalent compound, the opposite charges attract each other. Okay, so that's why they are able to dissolve in polar solvent, but they don't dissolve in non-polar solvent because non-polar solvent do not have any charge whatsoever. Okay, so B is correct. C is wrong because they don't conduct electricity in their solid state. They have to become molten or solutions before they are able to conduct electricity, so that the ions are able to freely move around, and the movement of the ions is what produces the current we observe. Then have mobile electrons. The mobile electrons are present in metallic bonds. Okay, so metallic bonds are formed between metals where their valence electrons are able to move around. They are mobile. So the correct answer is B. Question 16. Element X with this electronic configuration and element Y with this configuration are likely to combine by. So what kind of bond will be formed between X and Y? Let's see. So X, the configuration for X is 283, and that of Y is 287. What we observe here is X belongs to group 3 because it has 3 electrons on the outermost shell, and group 3 are metals and they easily lose their 3 electrons. The group 3 elements lose their 3 electrons to form 3+ ions. Now Y here has 7 electrons outside, so this is a group 7 element, and that's a halogen. So a halogen accepts 1 electron to become stable, so you're going to have -1 here. So notice that what we have here are ions. We have a positive ion and a negative ion. So when they combine together, we're going to get an ionic compound, or we're going to get an ionic bonding or an electrovalent bonding, because what are bonding here are ions. Okay, so the answer here would be B, electrovalent bonding. Okay, question 17. How many lone pair or pairs of electron or electrons is or are present in hydrogen fluoride? So let's draw the Lewis structure for hydrogen fluoride. Okay, so this is fluorine, belongs to group 7, so that means it has 7 valence electrons. So if we draw that, the Lewis structure for fluorine would have 1, 2, 3, 4, 5, 6, and 7. Okay, so there's only 1 unpaired electron, and that's where hydrogen bonds to here. So the number of lone pairs are the pairs of electrons that are not bonded. So we have 1 here, we have 2, and then 3 here. Okay, so there are 3 lone pairs of electrons here, and the 4th one is bonded to something else. So the answer is B. Question 18. Hydrogen bonds are formed between molecules containing a hydrogen atom bonded to a. Okay, so hydrogen bonds are formed between very, very electronegative atoms, like fluorine and oxygen and even nitrogen. That's where we have hydrogen bonds. So the correct answer is B, strongly electronegative atoms. Question 19. If a solid has a low melting point and dissolves readily in benzene, it would be... So compounds that have low melting points, that excludes ionic compounds. So it's most likely going to be a covalent compound. Now, it readily dissolves in benzene. Benzene is a non-polar solvent. So covalent compounds can dissolve in non-polar solvents. So this is most likely a covalent compound. Now, the reason it's not A is because the electrostatic force of attraction is found in ionic compounds, not covalent compounds. And then ionic compounds are the ones that conduct electricity in their molten state, not covalent compounds. So it has to be C. And then covalent compounds do not dissolve in water. It's ionic compounds that dissolve in water. So the correct answer is C. Question 20. If an element with high electron affinity combines with another element with low ionization energy, the bond formed will be... Okay, so elements that have high electron affinity are those on the very far right of the periodic table. So they're mostly very reactive non-metals, like the halogen group 7 or group 6 elements. So the other one is an element with a low ionization energy. Elements with low ionization energy are found on the far left, and those are reactive metals because they can easily lose their electrons. So it doesn't require a high amount of energy to get ionized. So it means that the reaction we're having here is between a metal and a non-metal. And the kind of bond that forms between a metal and a non-metal is ionic bond. So the answer is B. Question 21. If an element X with electronic configuration of this combines with another element Z with this electronic configuration, the compound formula would have what formula? Okay, so let's find out what the answer to this is. So X has a configuration of 2, 8, and 3. What this tells us is that X will easily lose these 3 electrons to form a 3+ ion. Now Z has this 2, 8, 6. So Z here has 6 valence electrons, but it needs 8 to be complete. So it would rather gain 2 electrons than lose the 6 electrons it has here. When it gains 2 electrons, it's going to form this ion -2. So it means the combining power of X is 3 and that of Z is 2. So when you cross them, okay, so 2 goes with X to give you X2, then 3 goes with Z to give you Z3. So the correct answer here is A. There we go. Question 22. If the atomic number of an element X is 11 and that of nitrogen is 7, the most likely formula of the nitride is... Okay, so let's figure that out. The atomic number of X is 11 and that of nitrogen is 7. So first off, the configuration for X would be 2, 8, and 1. So it has 1 electron on the outermost shell. So it will lose this 1 electron to form a +1 ion. While nitrogen, having 7 electrons, will have 2,5. So 2,5 means here it would gain 3 electrons to complete 8. So we're going to have -3 here. So this is the cation and this is the anion. When they form a formula or a compound, we exchange their combining power. So the combining power of nitrogen 3 here will go with X. So we have X3, and then 1 goes with nitrogen. So we have X3N1. But we don't write the 1, so it actually is X3N. Okay, so that's B. The correct answer is then B. 23. If the difference between the electron negativities of two elements is large, the type of bond that can be formed between them is, okay, so if we have a very large electronegative difference, we're going to get an ionic compound. But the lower the difference gets, as it approaches 0, then we get a covalent compound. So the correct answer here is A, ionic compound. 24. In any chemical reaction, the total mass of the product is always equal to that of the reactant. This is a statement of the law of K. So for the total mass of the product to be equal to that of the reactant, it means there was no loss in the mass. Although the mass can change form, but if you're able to get all the amounts together, you're going to get the same before the reaction and after the reaction, and that is the conservation of matter. So matter is not created nor destroyed, although it can transform from one form to another. So the correct answer is C. 25. In bonded atoms, increase in electronegativity difference. Okay, so how does it affect polarity? Polarity here in a molecule or a compound refers to the partial positive and partial negative sides of that compound. So if, for instance, we have a compound X and Y bonding together, okay, it's a covalent compound. Let's see. If we have X and Y, okay, not necessarily a covalent compound, but if we have X and Y coming together, okay, now the difference in electronegativity means that if the difference is very large, it means the sharing of this electron will not be equal. So the one that has a stronger grip on the electron would be the partial negative one, while the one that has a lesser grip will become the partial positive one. This is what we call polarity, where in the same compound, one side is partially positive, the other is partially negative. This is different from an instance where you have separate ions. Okay, so in this instance, if they're sharing electron, if the sharing is not equal, you're going to have a polar compound. So the larger the difference in the electronegativity, the more polarity you have, because the more electronegative one will pull the electron pair closer to itself than the other. So, but the lower the difference in the electronegativity, the less polarity you have. Okay, so the correct answer here would be that it would increase the polarity. If the electronegativity increases, there will be increased polarity. So the answer is D. Okay, 26. In metallic solids, the forces of attraction is between the mobile valence electrons and, so if you have a metallic compound, say, let's pick a metal, say zinc. If you have zinc atoms, what is holding zinc atoms together is the attraction between, let's see, so if this is zinc and this is zinc and this is zinc, there's actually a pattern. Okay, if these are zinc ions, and then these zinc ions have very mobile electrons around them. Okay, so because they are metals, they have mobile electrons around them. These electrons are negatively charged. What is keeping this bond together is the attraction between the negative electron and the positive proton that is in the nucleus of zinc atom. Because the structure of an atom is such that in the nucleus we have protons and neutrons, but protons are positively charged, and then outside we have electrons that are negatively charged. So there's an attraction between the negative electrons and the positive protons. So in a metallic compound, the attraction between the electrons and the nucleus or the protons is what keeps this together. So the correct answer would be the positively charged nuclei. Nuclei is just the plural for nucleus. So the positively charged nuclei is attracted to the valence electron, and that is why you have metallic bonds. So B. Okay, in metallic solids, forces of attraction are between the mobile valence electrons and the K. So the negative valence electron is attracted to the positive nucleus of that metal atom, and that's why you have a metallic bond. So it's attracted to the positively charged nuclei. A. In molecules, the bond angle is, so a molecule is formed between similar atoms. For instance, this is a hydrogen molecule, and that's why it's H2. An oxygen molecule will be oxygen bonded with oxygen double bond. A chlorine molecule would be chlorine bonded with chlorine. So notice that it's a straight line here. They are all linear. So, and in linear atoms, the bond angle is 180, because 180 is, straight line from one end to the other. This is 180 degrees. So when you have linear molecules, you're going to have a bond angle of 180 degrees, and that is D. So we'll go with D. 29. In which of the following compounds does hydrogen form ionic compounds? So ionic compounds are mostly formed between metals and non-metals. Hydrogen being generally a non-metal. Hydrogen is generally a non-metal. So for it to form an ionic bond, it has to bond with a metal. So if we look at these examples, the first one is nitrogen and hydrogen. Nitrogen is a non-metal. So they are both non-metal. So what you get there is a covalent bond, not an ionic bond. Hydrogen and chlorine. Chlorine is a non-metal. So what you get here is a covalent bond. Now sodium is a metal and hydrogen becomes the non-metal. So that should give you an ionic bond. The last one, you have carbon and hydrogen. They are both non-metal, so you get a covalent bond there. So the correct answer is C. 30. The total number of shared pair of electrons in the compound below is, so the lines we see here represents the pair of electrons that are shared. So in this case, this line represents 2 electrons. A pair is 2 electrons. So there's a pair of electrons being shared here. There's another pair being shared here, also here, and then also here. Then notice between the carbon atoms, you have 2 lines there. So it means there are 2 pairs of electrons here. So in total, the number of paired electrons that are shared are 1, 2, 3, 4, 5, and 6. So we have 6 pairs of electrons being shared here. So the correct answer is A. Question 31. In which of the following crystals are particles held by van der Waals forces only? So let's see. Ice. Ice is the solid form of water, and the water molecules are held together by hydrogen bonds. So A is not the answer. B, you have sodium chloride. Sodium chloride is formed between sodium ions and chlorine ions. And the bond between ions is called ionic bond or electrovalent bond, so it's not B. Iodine. Iodine molecules are held by van der Waals forces. So one molecule of iodine and another molecule of iodine is held by van der Waals forces. And then D, diamond. Diamond is formed from the covalent bond between carbon atoms. So in diamond, what you have is covalent bond between the carbon atoms. So the correct answer is iodine. Iodine molecules are held by van der Waals forces. 32. Molecules which are non-linear include, okay, let's see. So methane is CH4, so it kind of looks like one H, another H, another H, another H. Kind of looks like this. Now ammonia is nitrogen bonded with 3 hydrogen molecules. So this is just 3 hydrogen molecules to nitrogen. It doesn't look like this because here you have 4 bonds, here you have 3 bonds. Then with, let's see, hydrogen bond is linear like this. Between 2 hydrogen atoms, you have a hydrogen molecule, so it's linear. Then oxygen is also linear, although you have a double bond there. Okay, so the ones that are non-linear are this and this. Hydrogen and oxygen are linear, straight lines, while ammonia and methane are non-linear. So the answer is 1 and 2. Okay, so C. 33. Molecules which have the same shape as methane include, let's find out. So methane, carbon bonded to 4 hydrogen atoms. Okay, now let's see which one looks like this. Carbon chloride, so carbon bonded to 4 chlorine molecules. Okay, so we can see this kind of looks like this. So Roman figure 1 is correct. Now chlorine, 2 atoms of chlorine are linear like this. So this is linear. So that's not the answer. Or that doesn't look like a methane molecule. So what we have here is ethane. So 2 carbon and then 4 hydrogen molecules here. So 1, 2, 3. Oh, this is ethene, sorry. So there's a double bond between the carbon here. And then finally we have ethyne. So you have 1, 2, 3 bonds between the 2 carbon atoms, and then you have 1 hydrogen here and 1 hydrogen here. So this is linear. So the ones that kind of look like methane are this one and this one. So CCl4, tetrachloromethane, and the ethane molecule. So 1 and 3 should be the correct answers. Okay, we have 1 and 3, so that's B. Okay, 14. Ammonium ion is formed from ammonia and hydrogen ion by, what kind of bond is formed between ammonia and hydrogen ion? Now, using Lewis structure, ammonia looks like this. It has 5 valence electrons, then 3 hydrogen atoms are bonded with the unpaired electrons for nitrogen, so it has 1 pair of electron here. While hydrogen would usually have 1 electron, but then it lost that electron to become plus. So what happens is this pair of electron is shared between ammonia and hydrogen ion. So hydrogen can come and share this electron with ammonia. And the case that happens is called coordinate covalent bond or dative bonding, where the pair of electron is coming from one of the party, while the second one receives. So one donates the pair, the other one receives, and then they share together. So the correct answer would be dative bonding. Alright, 35. Noble gas molecules are held together by, so noble gases, the molecules of noble gases, although they exist as monoatomic gases, which means, what that means is, if you have a noble gas like argon, right, you don't see Ar2, argon is Ar, you don't see Ar2, it can stand as Ar, helium can also stand as helium, this way, xenon the same thing, okay, neon the same thing, alright, krypton also, I think that's a noble gas. They can all stand as monatomic gases. Now, one atom of argon is bonded to another atom of argon by van der Waals forces. Not covalent bonding, not ionic bonding, not all the other types of bonding that has to do with maybe sharing or transfer of electrons. Remember that noble gases have completely filled electrons. So the only way they can be attracted to each other is by a type of van der Waals force called, I think it's called London dispersion force. Okay, where a point happens where there's unequal distribution of electrons in each of those atoms. So that unequal distribution of electrons allow that for a very short period of time, each of these atoms can behave as polar atoms, and then they get attracted to each other. But then it's very short-lived, so it breaks and then combines again, and breaks and then combines again as the electrons are moving around. So it just happens when there's asymmetrical arrangement of electrons, and then they get attracted to each other. So the answer here is van der Waals forces, and the type of van der Waals force is called London dispersion force. Okay, 36. Positive ions in a sea of electrons are found in Okay, so the instance where we have a positive atom and then we have a sea of electrons moving around, mobile electrons are free to move around. So for instance, we see that in metallic bond. So if you have copper ions, copper that has lost its electron, but the electrons are still mobile around. So if you have copper ions, let's say you have copper 2 plus, yeah, okay, and then you have free electrons moving around here. The reason why the copper are held together is because the atom here, the nucleus here, is positive and then the electrons are negative, so the electrons are attracted to the positive nucleus of each of these atoms, and so you find that in metallic bond. So the correct answer is D. 37. Stoichiometry is based on the law of... Right, so what is stoichiometry exactly? Is when you have, it happens when you have a reaction. So for instance, if hydrogen gas reacts with oxygen gas, this is a gas, to give you water. Okay, it could be liquid water, it could be steam. So it's steam here, so it's gaseous. Now, stoichiometry allows that you can compare the quantities or the amount of each of these elements in this equation. So if you have a particular volume of hydrogen, you can compare it to the volume of oxygen to determine the volume of water you will get. And the only way you can do that correctly is if you balance the equation to make sure that the atoms are the same on both sides of the equation. So here we have 2 hydrogen atoms and 2 hydrogen atoms. But we have 2 oxygen atoms here and 1 oxygen atom. So we put a coefficient or a multiple 2 here, such that 2 times 1 will give you 2. But then hydrogen has become 4. So we come and put a 2 here. So the ratio here is 2:1:2. So if you're comparing their volumes or their moles, alright, you're going to use the coefficients we have here or their ratios. That's what stoichiometry is about. So for instance, if you have 5 centimeter cube of hydrogen gas, for oxygen gas is going to be half of that because the ratio is 2:1. So this will be 2.5 centimeter cube. Now, but water has the same ratio as hydrogen, so this would be 5 centimeter cube. So this is an instance of stoichiometry. And then the law that has to do with balancing equations to make sure that the atoms are the same on both sides is the law of conservation of mass, because it tells us that the mass remains the same before and after the equation. The amount of the mass you have there remains the same before and after. So the answer is C. Okay. 38. An atom of an element X has 2 electrons in its outermost shell. What is the formula of the compound formed when X combines with aluminium? Okay, so this is a hypothetical situation where if you have X and X has 3 electrons in its outermost shell, okay, so that means the combining power of X is 3. Now aluminium, which has an atomic number of 13, is 2,8,3. So the combining power of aluminium is also 3. X has 2 electrons in its outermost shell. Okay, and then the combining power of aluminium is 3 because it has 3 electrons that it can lose. So by the time you cross their combining powers, 2 goes with aluminium, so you have Al2, and then 3 goes with X. So you have something like this. So it's going to be Al2 X3. So of course this is a hypothetical situation, and the answer is A. Alright, 39. The atomic number of elements X and Y are 20 and 17 respectively. Which of the following compounds is likely to be formed by the combination of the 2 elements? So let's figure out what their combining powers are. X has an atomic number of 20 and Y has an atomic number of 17. So let's see, 20 is 2, 8 and 2. it's going to lose these 2 electrons, so you have a combining power of 2. 17 is 2, 8, and 7. So it has 7 electrons outside. It will accept 1. Okay, so the combining power is 1. So when you exchange this, oh, and remember, this is plus 2 and this is minus 1. So when you're writing the formula, the cation comes before the anion, so it has to be x and y. So the combining power 1 here goes with x and 2 goes with y. So you're going to have x1, y2, which is just xy2. So it means the answer here is D. Okay, 40. The bond angle in a tetrahedral molecule such as tetrachloromethane is, when you have a tetrahedral molecule, it actually kind of looks like this. So let's draw tetrachloromethane. Tetrachloromethane is CCl4. So if you draw tetrachloromethane, there's carbon in the middle here. This is chlorine, this is chlorine, this is chlorine. So the image looks something like this. So the angle here is 109.5. Okay, so when you have a tetrahedral molecule, the angle there is 109.5. So the correct answer is D. Question 41. The bond formed between water and hydrogen ion to form the hydrozonium ion. Okay, so what bond is formed between water and hydrogen ion to give hydrozonium ion? Let's find that out. If you have a water molecule, usually you have oxygen with 1, 2, 3, 4, then say 5 and 6. So the one hydrogen bond here, another hydrogen bond here. So you have 2 lone pairs of electrons. Now if you have a hydrogen ion that has lost 1 electron, it's going to have an empty shell. Okay, so because it has an empty shell, it can share one of the lone electrons that are here. Okay, so that will be shared with hydrogen ion. And this type of bond is called dative bond, where the pair of electrons is coming from one of the 2 of them. So one is donating the pair, the other is receiving the pair, and then they share together. The correct answer is B. Dative. Okay. 42. The bond formed when ammonia reacts with hydrogen ion to form ammonium ion is. So we use the Lewis structure also. Lewis structure for ammonia. This is nitrogen with 5 outermost electrons. You see, this is 5. So 1 hydrogen bonds here, another hydrogen bonds here, and another hydrogen bonds here to give us NH3. Okay. Then when it combines with a hydrogen ion is a hydrogen atom that has lost 1 electron. And since hydrogen has only 1 electron, that means the shell is empty. So it can share the bonded electron, the lone electron pair we have here. So ammonia can donate this lone electron pair to hydrogen ion, and then they share it together. So when the electron pair is coming from one of the 2 of them, you have dative bonding. So this is dative bonding to give you ammonium ion. B. 43. The bond formed when 2 electrons that are shared between 2 atoms are donated by only one of the atom is. This is an example of coordinate covalent or dative bonding, where the electron pairs that are shared is coming from one of the 2 atoms or molecules, and then the other one is accepting the bonded pair, and then they share the pair of electrons together. The correct answer is D. Question 44. The bond in crystalline ammonium chloride are, so there are multiple bonds in ammonium chloride. Let's find out what bonds are in ammonium chloride. Ammonium chloride is formed when an ammonium molecule, NH4 plus, this is ammonium, combines with chlorine ion. So first off, this is a positive ion combining with a negative ion to give you, this is ammonium chloride. So the type of bond between the both of them here is ionic, because it has to do with two ions. Okay, so the first bond we can find here is ionic bond, but then for ammonium to be formed, it has to come from ammonia and hydrogen ion. So this is ammonia plus hydrogen ion. Okay, and so hydrogen ion shares this pair of electron with ammonia, and then the kind of bond you have here is dative bond, where the one pair of electron is coming from ammonia and then hydrogen gets to share that pair of electron. So we found dative bond. Now, but between the hydrogen and the nitrogen here, this sharing of electron that is happening here and here and here, that is covalent bond. So the sharing happening here between nitrogen and hydrogen is covalent bond. So we have ionic, we have covalent, and then we have dative bond. So that would be D. Yeah, so the answer is D. (45) A compound formed between X and Y is, so we have the atomic numbers for X and Y. What we do is we find their combining power. So X having 14 electrons would be 2,8,4, and then Y having 16 electrons would be 2,8,6. Now, elements in group 4 of the periodic table would most likely, let's see. Okay, so the combining power here is 4, and the combining power here for it to complete 8 is 2. So it's going to need 2 electrons to make this 8. So we found the combining power. When you exchange their combining powers, the 2 goes with X, so you have X2, Y4. Okay, and X2, Y4 can be reduced to its lowest term. So 2 in here 1, 2 in here 2, so finally you can have XY2. Okay, so the correct answer would be A. So A. 46. The compound formed by the combination of two elements with a large electronegativity difference is likely to be, if we have a very large electronegativity difference between the atoms or elements, what you're going to have is an ionic bond. The lesser the difference in electronegativity, the more covalent it becomes. But the larger the electronegativity difference, you get an ionic bond. So the answer is B. 47. The crystal layers in graphite are held by, so graphite is an allotrope of carbon. So graphite has carbon atoms bonded together, but then the structure of graphite is such that it is in layers, and these layers can slide over each other because the bond between the layers is a weak van der Waals force, or a weak van der Waals bond, and that's why it's able to slide over each other. And that's the reason why graphite can be used as a lubricant, because of how the layers slide over each other, and so there's fluidity there. So the answer is A. 48. The crystal layers in graphite are held together by, so the layers in graphite are held together by van der Waals forces, and because they are weak forces, the forces are not very strong, and that's why the layers are able to move over each other. So the answer is 4 only. 49. The following compounds contain the same type of bonds except, let's find out. Sodium chloride is formed from sodium and chlorine. Sodium and chlorine, sodium is the metal, chlorine is the non-metal, so this is going to be an ionic bond between metals and non-metals. Hydrogen chloride, okay, so hydrogen chloride is a covalent bond because hydrogen and chlorine, if you check their electronegativity difference, is less than 2. And if the difference is less than 2, you get a covalent bond. And then plus, hydrogen is a non-metal, and then chlorine is also a non-metal. So non-metals forming together will give you covalent bond. For C, potassium and chlorine. Potassium is a metal, chlorine is a non-metal, so this is ionic bond. Magnesium chloride will give you magnesium as a metal and chlorine as a non-metal. So this will give you ionic bond. So all the others are ionic bond except hydrogen chloride. 50. The following molecules have double covalent bonds between two atoms except... Okay, so let's use the Lewis structure for the atoms that give us this compound and see which one have double bonds or which one does not have double bond, because the question says the following have double covalent bonds except. So with water is formed from oxygen and nitrogen. So oxygen having 6 electrons outside, 2 paired, 2 unpaired. So one hydrogen gets paired here, another hydrogen gets paired here. Okay, so when you have one pair of electrons, you have one covalent bond or a single covalent bond there. So in oxygen, there's a single covalent bond here and there's a single covalent bond here. Okay, and that's why water looks like this. So this is a single covalent bond. But for carbon dioxide, carbon has 4 electrons outside. So the structure for carbon, the 4 electrons come this way. Then you have oxygen also sharing 2 electrons here. So this is what carbon dioxide looks like. Oxygen has 6 electrons, so 1, 2, 3, 4, 5. Okay, so this is not here. So the 2 unpaired electrons of oxygen bonds with carbon. Let's eliminate this one. Okay. All right. So 1, 2, 3, 4, 5, 6 of oxygen, and then carbon has 4. 1, 2, 3, 4. So you have a double bond here. Notice you have a double bond here, and then you have a double bond on the other side, and that's why carbon dioxide is linear. So let's see, there's a double bond, one bond here and another bond. So one bond stands for a pair of electrons. So we have 2 pairs and 2 pairs here. So we have double bonds. Ethene is C2H4. So for C2H4 to be formed, you need to have a double bond between the carbon atoms. Okay, so you have a double bond here. That means there's a double covalent bond here. Oxygen atoms are held together by double bonds also. So the exception here is water. All the other ones have double bonds except water. So the answer is A. Question 51. The force of attraction between covalent molecules is... So covalent molecules are held together by van der Waals forces. So if, for instance, you have a covalent molecule such as hydrogen gas is H2, which means there are 2 hydrogen atoms bonded together. So if you have a bunch of hydrogen molecules, okay, what attracts this to this or this to this is a van der Waals force. So the answer is D. Alright. 52. The formation of a bond between hydrogen and a highly electronegative atom results in... When hydrogen bonds with a very electronegative atom like fluorine or oxygen or nitrogen, what you get is a hydrogen bond. But then if it is highly electronegative, it means that the covalent bond that is formed, the hydrogen bond that is formed would have polarity, meaning a part of it will be positive and the other part would be negative. So when hydrogen bonds with oxygen, oxygen is partially negative, hydrogen is partially positive. Same thing with hydrogen fluoride. The fluorine there is partially negative and then the hydrogen is partially positive. So usually you're going to end up with a dipole. So a dipole is just a molecule where there are 2 poles, where one pole is positive and then the other pole is negative. So that happens in hydrogen bonds. You're going to get a dipole. The formation of the compound, the formula of the compound formed between a trivalent metal M and a divalent metal Y. A divalent non-metal Y is, let's see. So M is a trivalent metal. What that means is that it has 3 electrons outside that it loses, so it's going to lose 3 electrons to form +3. A divalent non-metal, why? Divalent means, let's see, it gains 2 electrons, okay? So when you cross this, it gains 2 electrons because a non-metal. Non-metals gain electrons, metals lose electrons. So when you cross their combining power, 2 goes with M, so you have M2, and then 3 goes with Y, Y3. So always remember the metal is written before the non-metal, or the cation is written before the anion. So M2Y3, and that's A. Alright, 54. The high solubility of ethanol in water is due to, okay, so although ethanol is an organic compound, it's a hydrocarbon, sorry, it's able to dissolve in water because, so ethanol is CH3OH, or C2H5, sorry, that's methanol, C2H5OH, okay? So carbon, 1, 2, 3, and then you have OH. Yeah. So you have 5 hydrogen atoms here, covalently bonded to carbon. Okay. So although ethanol contains covalent bond, why is it able to dissolve in water that is a polar solvent? The reason is because of the presence of hydrogen bond. So there's hydrogen bond here between O and H. Okay. So when hydrogen bonds with oxygen, which is highly electronegative, you're going to get a hydrogen bond. And then it gives a partial negative and partial positive sign here. And that's why, because of that partial charges, it's able to dissolve in water. So the answer is hydrogen bond A. 55. The law of definite proportion states that, okay, so the answer is that pure samples of the same compound contain same elements combined in the same proportion by mass. What that means is that if you have a compound, regardless of the source of that compound, regardless of how it was gotten, if it is pure, it's going to contain the exact same element in the same proportion. So water, for instance, will always be H2O. It will always have 2 atoms of hydrogen, 1 atom of oxygen, as long as it is pure, regardless of where you get the water from. So same thing with ammonia, regardless of how you get ammonia, if it is created in the lab, if it is from the decay of organic matter, it doesn't matter what the source is, it will always contain nitrogen and 3 hydrogen atoms. So that's the law of definite proportion. So the answer is A. 56. What is the likely formula of a compound formed between element M in group 2 and X in group 7? So let's see. M is in group 2, which means it has 2 electrons outside, right? So it's most likely a metal because it will lose that 2 electrons when it combines. Now, X is in group 7. So group 7 means it has 7 electrons in the outermost shell. With 7 electrons, it's going to gain 1 electron to become stable, or when it combines. So the oxidation number is -1 and the valency is 1. So when you cross this over, you're going to have M1X2, which is just MX2. So the answer is A. A. 57. The maximum number of covalent bonds formed by nitrogen is... Okay, so let's draw the Lewis structure of nitrogen to find out how many covalent bonds would nitrogen form. Nitrogen is in group 5. It has 5 valent electrons, 1, 2, 3, 4, and 5. Okay, so it can share, electrons can be shared within this 3 unpaired electrons. So for instance, hydrogen can actually share here, and share with this other one, and share with this other one. Okay, so you can have 3 covalent bonds here because they are sharing the electrons. So there are 3 covalent bonds. Now, notice that there's a lone pair of electron here. This lone pair allows it to form a dative bond. A dative bond is also a type of covalent bond, but this time around, the electron pair is coming from just one of the atom, and then ammonia is a good donor of electron pair because it has a lone pair. So it can combine with any other atom or molecule that needs an electron pair. So it can form one type of dative bond or coordinate covalent bond. So altogether, it would form 4 covalent bonds. 3 ordinary covalent bonds and 1 coordinate covalent bond. So the correct answer is B. (58) The molecule that has a non-polar covalent bond is. So for a molecule to have non-polar covalent bond, it means that the electronegativity difference between the atoms is practically 0. So if you check the atoms that combine here, a non-polar covalent bond will form if you have 2 atoms that are the same, that have the same electronegative value such that the difference between their values would be 0. So chlorine, for instance, formed from 2 chlorine atoms. If for instance the electronegative value of chlorine is 0.4, it's also 0.4. By the time you get the difference, 0.4 minus 0.4, you're going to get 0. So this is a non-polar covalent bond because they are sharing the electrons equally. So there's a 0 there. The difference is 0. But for the other ones, each of these elements, they have different electronegative values. So none of these will give you 0, which means chlorine is the one that is closest to having a non-polar covalent bond than the other ones, because the other ones will still give you a value when you subtract their electronegative values. So the answer is chlorine here. 59. The molecule which has a linear shape is, okay, so this is shape of simple molecules. For CO2, this is the shape of CO2. This, notice, is linear, straight. Now H2S, let's see. So H2S is where you have sulfur, and then there's hydrogen here, then there's hydrogen here. Okay. Then methane is tetrahedral, and then you have H here. Then ammonia is trigonal planar, this way. So the linear one here is CO2. Okay. So A. (60) The properties of electrovalent compounds includes the following except. So let's see, electrovalent compounds have high melting and boiling points because of the strong force of attraction between the ions. So it takes a lot of energy, heat energy, to break the ionic bond between them. Now, they do ionize in solution. So for instance, sodium chloride can ionize in solution to give you sodium ion and chlorine ion. So this is also correct. Now, high volatility at room temperature. Volatility describes the property of a liquid to change phase into gas without much external heat applied to it. So it's like the bond between the molecules in liquid phase is very, very weak, such that it can easily convert into gaseous molecules when the bonds break. And that's usually a property of covalent compounds, not electrovalent compounds. So we found that the answer is C, because electrovalent compounds also conduct electricity. So D is a property of electrovalent compounds. So the correct answer is C. Question 61. The properties of 4 compounds P, Q, R, and S are shown in the table below. Which of them is ionic? So here we consider the properties of ionic compounds. The 2 properties we have here are the electrical conductance and the melting point. So ionic compounds are good conductors of electricity. So that eliminates Q and R. So it's either P or S. But if you consider the melting point, ionic compounds generally have high melting point. So which means of P and S, S would be most likely an ionic compound because it has a very high melting point, and it's also a fairly good conductor of electricity. It's molten state, so we'll go with S. 62. The shape of a graphite crystal is, so graphite has a hexagonal shape. 63. Shape of a graphite is hexagonal, D. The shape of a molecule of water is, okay, so water is made from 2 hydrogen atoms and 1 oxygen atom, but it actually looks like this. So it's either called V-shaped or it's called bent. But since none of this is in the options, the one that is closest to what water looks like would be non-linear. So linear means straight, a straight line, but notice it's not straight, it's actually bent. So this is a non-linear shape. So it means the best answer there would be C. '65. The shape of methane is, so methane bonded to 4 carbon atoms looks tetrahedral. Okay, and a tetrahedral shape is this way. You have the carbon in the middle. So there are 3 hydrogen atoms on the lower side, and then there's 1 hydrogen atom at the top. So this is a tetrahedral molecule, and the bond here is 109.5 degrees. So the answer is D. '66. The shape of water molecule is, okay, so the shape of water molecule O and 2H is V-shaped. It's either called V-shaped or bent or non-linear. So the answer is B. The solubility of carbon dioxide in water can be accounted for. So water is a polar compound, a polar substance. Polar meaning it has partial positive and partial negative signs. So this is partial positive, this is partial positive, and this is partial negative. So this happens when there is unequal sharing of electrons between them. So the most electronegative one draws the electron and becomes partially negative. So the only kinds of compounds that can dissolve in water are those that have charges. So it means all ionic compounds can dissolve in water because ionic compounds are made of ions and ions are charged. But now this is carbon dioxide. Carbon dioxide is not an ionic compound. So why exactly is it able to dissolve in water? The reason is because the electronegativity difference between carbon and oxygen is actually relatively high. So there's going to be a partial negative and partial positive sign here. Okay. So the oxygens are pulling the electron, the shared pair of electron, closer to themselves than carbon. So because there's a partial charge here, it's going to dissolve in water so that the negative aspect gets attracted to the positive part of water. And so the reason for that is dipole attraction. Dipole meaning there are 2 different charges there on either poles. Okay, so it's dipole attraction that makes CO2 soluble in water. '68. The strength of metallic bond depends on. So metallic bond is formed when the free electrons in metals get attracted to the positive nucleus of those atoms. Okay, so the reason why metallic bond can get stronger is if the number of electrons outside are more. So the higher the valence electrons, the stronger the metallic bond. So it means the answer is A, number of valence electrons. That is what influences the strength of a metallic bond. 69. The type of chemical bond that exists between potassium and oxygen in potassium oxide is, so potassium is a metal and oxygen is a non-metal. Potassium would lose electrons to become positive and oxygen would gain electrons to become negative. So they both form ions, and those ions get attracted by electrostatic force of attraction. So that would form an ionic bond. So the answer is D. Alright, 70. The van der Waals forces are dominant intermolecular forces in... Okay, so usually the van der Waals forces happen between purely covalent compounds or noble gases. Okay, so the purely covalent compound here is chlorine. Covalent molecule, sorry, because you have two chlorine molecules giving you a chlorine, two chlorine atoms giving you a chlorine molecule. And what attracts, because there's no charges there, so what keeps the chlorine molecules together are van der Waals forces. For ammonium chloride, it's ionic bond between ammonium ion and chlorine ion. For water, you have hydrogen bond there. Sodium chloride is also ionic bond between sodium ion and chlorine ion. So the correct answer here is chlorine. So question 71. Use the following information to answer this question. A metal X forms two chlorides with the formulas XCl2 and XCl3. What type of bond exists between X and chlorine in each chloride? Okay, so from the formula we can see that the combining power of X in both chlorides are 2 and 3 respectively, while the combining power of chlorine is 1. What that means is in XCl2, okay, in XCl2, the combining power of X is 2, which means it loses 2 electrons to form +2, while chlorine is -1. So when they cross, you get XCl2. In XCl3, the combining power of X is +3, so it loses 3 electrons, and then chlorine gains 1 electron to become -1, and that's why you have this. So they are both ionic compounds because they are formed between ions. So X is the cation there and chlorine is the anion there. The correct answer would be A. (72) Water molecules are held together by... So what holds water molecules is hydrogen bonds. Hydrogen bonds between hydrogen from one water molecule, and oxygen from another water molecule. So if you have a bunch of hydrogen molecules, okay, let's just draw 2 of them. The bond that holds these 2 molecules together is the attraction between the hydrogen from one molecule and then the oxygen from the other, and this is called hydrogen bond. When hydrogen is attracted to a very electronegative element on another molecule, you get a hydrogen bond. So the answer is A. What is responsible for metallic bonding? Metallic bonding is formed when the valence electrons of metals get attracted to the positive nucleus of the metallic atoms. So it's like an attraction between the nucleus of the atom and then the negative electrons that are moving around. That's what strengthens a metallic bond. So the answer would be attraction between atomic nuclei and clouds of electrons. Okay, so the answer is A. What is the percentage by mass of copper in copper 1 oxide? All right, let's calculate this. Percentage by mass represents, we have to look for the molar mass of copper oxide. So in doing that, copper is 64. So 64 times 2, so 2 atoms of copper plus 16. Okay, so 64 times 2 plus 16, let's check that. 64 times 2. Okay. Then plus 16. It will give us a total molar mass of 144. So it means the total molar mass of copper 1 oxide is 144 grams per mole. So if you want to find the percentage by mass of copper, you're going to have to do the total mass, atomic mass or molecular mass of copper here over the total molar mass of the whole compound times 100. Now notice copper is 64, but there are 2 atoms of copper, so we're going to take 64 times 2 as the total mass for copper. then divided by the total. Now 64 times 2 is 128. So it means we have 128 over the total mass, which is 144 times 100. So when we compute that, we're going to have 128 divided by 144, then times 100 would have 88.8. 88.888 is a reoccurring, it's a repeating decimal place value, so it's going to be 88.9. So the answer is A. Okay, so when you want to calculate the percentage, you get the mass of that atom over the total mass of the whole compound times 100. That will give you the mass percentage. So the answer is A. What is the percentage composition of carbon in, okay, so in carbon, hydrogen, carbonate? So it means we have to find the total molar mass of the whole compound, and then to find that of carbon, it become carbon over the total times 100. So first of all, let's find the total molar mass of this compound. So calcium, hydrogen, deoxycarbonate. So for calcium, we have one atom of calcium, so 40, then plus. We can decide to solve this and then multiply it by 2, or you can open the bracket with the 2 and then find the molar masses. But let's solve everything in a bracket. So hydrogen is 1, okay, plus carbon is 12. Then we have 3 oxygen atoms, so 16 times 3. Then when you're done, you multiply everything by 2 because of the 2 outside here. So it means we have 40 plus, so 16 times 3, that's 48. 48 plus 1 is 49, and then plus 12 would give us 61. So it means 61 times 2 now, okay, because of the 2 outside. So we'll multiply 61 by 2. So 61 times 2 would be 122. Then plus 40, that's 162. So the total mass of this compound is 162 grams per mole. So if you want to find the percentage for carbon, we take the mass of the total number of carbon atoms we have here. Notice there is 2 outside here, so it means there are actually 2 carbon atoms here. So 2 carbon atoms will mean 12 times 2, okay, for the carbon atoms over the total mass times 100. Okay, so we would have, let's see what this would give us. 12 times 2 is 24, so 24 divided by 162 times 100 is 14.81. So 14.814. So this means the answer is B. Alright, 76. What is the shape of a molecule of tetrachloromethane? This is tetrachloromethane. So it has a tetrahedral shape. So the carbon bonded to 4 chlorine molecules will give us a tetrahedral shape. What type of bond is formed by the dotted lines in the following structure? Okay, so notice that there are dotted lines here, and then there are those that are not dotted. So the one that is not dotted between hydrogen and fluorine is a covalent bond. But then from one fluorine in one of this atom to another hydrogen on another atom would give you a hydrogen bond. So fluorine is a very electronegative element. When it combines with hydrogen on another molecule, you get a hydrogen bond. So the dotted lines here show us that we have hydrogen bonds between the hydrogen fluoride molecules we have here. So the answer is A. Okay, 78. What type of bond is indicated by the arrow in the following structure? Okay, so this arrow here means that there was a bond formed between ammonia and hydrogen ion that gave us this. So this compound is, let's write that. This compound is actually ammonium ion. This is just a compound. Now ammonium ion is gotten from ammonia reacting with hydrogen plus. Okay? So when ammonia reacts with hydrogen plus, remember that ammonia has a pair of lone electrons. Let's see. Okay. And then hydrogen here is an empty orbital. So what happens is they share this lone pair of electrons between each other, and that kind of bond is called dative bond. So it means that the arrow we see here between ammonia and then H plus is actually a dative bond. The correct answer is D. 79. What type of bond will be formed between elements P and Q if their electronegative values are 0.8 and 4? Okay, so there's a range with which we know the kind of bond that is formed between elements based on their electronegativity values. So if we have a difference of greater than 2, you're going to have an ionic bond. Actually, greater or equal to. If you have greater or equal to 2, you have an ionic bond. If you have a difference between 0.5, okay, and let's say 1.9, you're going to have a polar covalent bond. Then if you have less than 0.5, what you have is a pure covalent bond or non-polar. Alright, so let's get the difference between this and this. If you do 4 minus 0.8, you're going to have 3.2. And 3.2 is above 2. So you definitely have an ionic bond. Okay, so the answer here is D. (80) What type of chemical bond is involved in the formation of ammonium from a molecule of ammonia and a proton? Okay, so ammonia is NH3. Okay. With a single, with a pair of electrons here that is not bonded. Then a proton is just a hydrogen atom that has lost its electron, so the shell is empty. So it only has one proton, it doesn't have any electron. So what happens is they share this lone pair of electrons. So ammonia donates this lone pair of electron, and then hydrogen receives, and then they share it. So that type of bond is called a coordinate covalent bond or a dative bond. So from the option, what we have there is a coordinate covalent bond, so that's D. Question 81. When an ionic bond is broken, bonding electrons are... So what happens here is the electrons get attracted to the more electronegative atom there, or the most electronegative atom there, because electronegativity measures the ability of an atom to accept or gain electron to itself or attract electrons to itself. So the electrons will most likely go with the atom that is most electronegative, and it means the correct answer here is C. 82. When an element A with atomic number of 20 bonds with an element Y. Okay, so let's see what kind of compound we get from that and what the formula will be. So A with atomic number 20, the configuration is 2,8,8,2. So all of these will give us 20, which means it's more likely to lose these 2 electrons to form a +2 ion. Why an element Y with 8 electrons would be 2,6. So it would gain 2 electrons to make it 8 here. So it's going to gain 2 electrons. So the 2 electrons that are lost here are gained by Y here. So it means we're having a bond between 2 ions, a positive and a negative ion. So we'll have an ionic bond. But what then is the formula? Once you cross this, okay, you're going to have A2Y2. And in their lowest term, 2 cancels 2, so we have AY. So it means it's to give us an ionic compound, and AY is formed. So that's A. Okay, so this is A here. Okay, so when an element Y combines with an element Z, what do we get from that? Okay, so an element Y with atomic number 20 would have a configuration of 2, 8, 8, 2. So all of this gives us 20. So it would most likely lose the 2 electrons here and forms a +2 ion. The other element Z with atomic number 8 would be 2, 6. So it would gain 2 electrons here to complete 8. So it's going to gain 2 electrons. So the 2 electrons that are lost here are gained by Z on this other hand. So we have a bond between 2 ions, a positive and a negative ion. So this is going to be an ionic bond. And then the formula, when you cross them, you have Y2, Z2. Then 2 cancels 2 out, so you just have YZ. Okay? So here would have, and then notice that some of the options put Z before Y, but remember that the cation is written before the anion, so it's actually YZ in the order YZ. So it means you have an ionic compound and YZ is formed, and that is B. Which of the following bond type is intermolecular? So intermolecular means a bond between molecules, not just atoms now, between molecules. Now metallic bond is not the answer because metallic bond is just a cluster of metal ions or metal atoms with a pool of electrons moving around, and the electrons are attracted to the positive nucleus. So it's not metallic bond. For covalent bond happens within 2 atoms. Okay, so it's not intermolecular, it's within a molecule. Ionic bond is between ions, so that's not intermolecular. But hydrogen bond is intermolecular because it's formed between hydrogen from one molecule and then another electronegative element of another molecule. So it's from one molecule to another. That's why the answer is hydrogen bond. 85. Which of the following bond types is responsible for the high boiling point of water? Okay, so the reason why water has a high boiling point is because it has hydrogen bond. It doesn't have ionic bond and doesn't have metallic bond. The covalent bond is between the hydrogen and oxygen atom. But then when you boil water, the bonds that break is the bond between one molecule of water and another molecule of water, and that bond is hydrogen bond. 86. Which of the following bonds are broken when ethanol is boiled? So ethanol has the formula C2H5OH. So it has an OH functional group. You have OH here. Okay. So the OH here, this is partially negative and this is partially positive. Okay. Now, the reason why so there's a hydrogen bond from one ethanol molecule to another. If I have another ethanol molecule here, and I have O and I have H here, what happens is the positive aspects here get attracted to hydrogen here, and this is a hydrogen bond. So when this is heated, the bond that is broken here is the hydrogen bond. Okay, and that's 3. So the answer is 3 only. Not covalent bond, because the covalent bond between carbon and hydrogen stays intact. It's not broken. Then this does not contain an ionic bond. So the answer is just hydrogen bond. And that's option B. 27. Which of the following can be used to predict the type of bonding in hydrogen chloride? So the property that we use to check the type of bond that is formed is the difference in electronegativity. The larger the difference in electronegativity, the more ionic bond you get, while the lesser the electronegativity, the more covalent bond you get. The answer is C. 88. Which of the following compounds has coordinate bonds in its structure? Okay, so let's eliminate the ones we are sure do not have coordinate bonds. Now, silver chloride is an ionic compound. Okay, so silver +1 bonds with chlorine -1. So the electrons that are lost from silver are gained by chlorine. So this is ionic bond. Sodium chloride, the same thing. The electron that is lost from sodium is gained by chlorine. So this is an ionic bond. Now, for D, we have magnesium chloride. This is also ionic because when magnesium forms an ion, it forms +2 ion. and then there are 2 chlorine atoms here. So each of them having -1 will become -2. So the 2 electrons that are lost by magnesium are gained by each of the chlorine atoms. So we're only left with this compound here. This compound is going to give you a coordinate covalent bond. Okay, so let's see what that looks like. So the structure is actually, you have 1 aluminium here. Aluminium usually has 3 unpaired electrons. So let's say chlorine is bonded here, chlorine is bonded here, and chlorine is bonded here. Then another aluminium here. Okay, 1, 2, and 3. So chlorine is bonded here, chlorine is bonded here, and chlorine is bonded here. What happens is, you see the chlorines we have here, they also have lone pairs of electrons. Okay. So this makes it 8. It has 3 lone pairs of electrons, and then it shares the 7th one with aluminium. So each of these chlorine atoms have their lone pairs of electrons. So what happens is, the lone pair from 1 chlorine atom here can get shared with the aluminium here. So aluminium is able to accept a lone pair of electrons from the chlorine here. The same thing can happen between a bonded pair of electrons here and this aluminium here. So when the pair of electrons is coming from one party and then the other one shares it, you have a dative bond or a coordinate covalent bond. So it means the answer is Al2Cl6. Okay, so C. 89. Which of the following compounds has hydrogen bonds between its molecules? So hydrogen bonds is formed between hydrogen and a very electronegative element. Of all those halogens we see here, the most electronegative is fluorine. So it means hydrogen and fluorine would give us hydrogen bond because of the electronegativity, the high electronegativity of fluorine. So the answer is hydrogen fluoride. Which of the following compounds has the highest ionic character? Okay, so first of all, silicon chloride is a covalent bond because silicon is acting as silicon here as a non-metal combines with chlorine, a non-metal, to give you a covalent bond. Phosphorus and chlorine here are both non-metal, so you get a covalent bond. Now potassium and chlorine, potassium is a metal, chlorine is a non-metal, so you get an ionic bond here. But aluminum chloride could also give you an ionic bond because the 3 atoms lost by aluminum can be gained by the 3 chlorine atoms we have here. So, but of these 2, which has a stronger ionic character, that can be determined by the electronegativity difference. The larger the difference in electronegativity, the more ionic it is. Now, potassium is in group 1, but aluminum is in group 3. Chlorine is in group 7. So from 1 to 7, in this case, the difference is very large. While in this case, from group 3 to group 7, the difference is not as much as from group 1 to group 7. So it means potassium chloride has a more ionic character. Question 91. Which of the following compounds has the lowest boiling point? We can measure the boiling point by checking the type of bond that is present here. So the one that is most covalent would give you a low boiling point. Okay, so if you look at water, water is a polar covalent compound. So the polarity there gives it a relatively higher boiling point than most covalent compounds. Okay? And then it has hydrogen bond there, so it has a higher boiling point than most covalent compounds. For this is ethanol. Ethanol also has hydrogen bond because of the OH here. So because of the presence of hydrogen bond, it doesn't have as low a boiling point as would expect covalent from a covalent compound. Now this is butane. Yes, this is butane. So butane is purely covalent. Okay, so because it's purely covalent, it will have the lowest boiling point here. This is ethanoic acid. So because of the carboxylic acid here, the functional group COOH bonded here, it's not going to have as low of a boiling point as other covalent compounds. So the most covalent compound here is butane. So that will have the lowest boiling point. 92. Which of the following compounds is covalent? Okay, so let's see the nature of the atoms that are bonded together. Here, carbon and hydrogen bonding together will actually give you a covalent bond. Let's see the other ones. Magnesium and oxygen. Magnesium is a metal, oxygen is a non-metal, so this is most likely an ionic bond. Sodium hydride. So sodium will act as the metal here and hydrogen will act as the non-metal here. So you would have an ionic bond here. Then calcium chloride. Calcium is the metal, chlorine is the non-metal. You also have an ionic bond. So it means methane is what gives you equivalent bond here. Question 93. Which of the following contains coordinate covalent bond? Okay. So methane is formed from a covalent bond between carbon and hydrogen. This is ammonium, NH4. And ammonium is gotten from NH3 and H+. Okay. So it's gotten from NH3 with a lone pair of electron here. And then H+. H+ is a proton because it has no electron. So this lone pair of electron will be shared between both of them. Then you get a dative bond or a coordinate covalent bond. Sodium chloride here is an ionic bond because sodium is a metal, chlorine is a non-metal. Then hydrogen chloride here will most likely give you equivalent bond because the electronegativity difference between hydrogen and chlorine is such that you get a covalent bond here. So the one with the coordinate covalent is ammonium, B. (94) Which of the following groups contains entirely linear molecules? Okay, so let's check what the molecules what the shape of the molecules we have here, and then we can figure out which option has only linear molecules. Now for hydrogen gas, okay, hydrogen gas is this way, two hydrogen atoms bonding together, and then you get something linear. Now, but ammonia is not linear. See that's not linear. Okay, so NH3 is not linear. This is. Then what else do we have? We have carbon dioxide. So carbon dioxide is this way. So it means this is linear. It's straight, so it's linear. What else do we have there? Methane. Methane is carbon bonded to 4 hydrogen atoms. So this is not linear. Okay, nitrogen gas is from 2 nitrogen atoms. So this is linear. I think that is it. So it means we are looking for the option that has hydrogen gas, carbon dioxide, and nitrogen gas. Okay, and it looks like that's option B. So the answer here would be B. (95) Which of the following metals has the strongest metallic bond? So the metallic bond, the strength of the metallic bond for metals is measured by how many valence electrons it has. So it means from group 1 to group 3 of the metals, group 3 will have a stronger metallic bond than group 1 because group 3 has 3 electrons outside. Group 1 has only 1 electron outside. So as the valence electron increases, so does the metallic bond. So it means the answer here will be aluminum because aluminum is in group 3, magnesium is in group 2, potassium is in group 1, sodium is in group 1. So it means that aluminum has a stronger metallic bond than the rest of them because it has more valence electrons. 96. Which of the following molecules has a linear shape? Okay, so CO2 is linear, ammonia has a trigonal planar, so nitrogen and 3 hydrogen atoms. Hydrogen sulfide is kind of bent. Okay, let's just do a quick drawing of what they look like. So this is CO2, this is ammonia, this is hydrogen sulfide, then this is methane. 4 hydrogens this way. So it means the linear molecule here is carbon dioxide, which is A. So which of the following molecules has linear structure? Methane is tetrahedral, water is bent, ammonia is trigonal planar, so the only linear one here is carbon dioxide. Which of the following molecules is linear in shape? Okay, methane is tetrahedral, water is bent, chlorine is linear. When you have 2 chlorine molecules, you get a straight line, while ammonia is trigonal planar, so the only linear one here is chlorine. Which of the following molecules is not linear in shape? Not linear. Okay. So the one that is not linear here, let's see. CO2, of course. Let's draw that and see. CO2 has carbon in the middle and oxygen here, so it's linear. Hydrogen chloride is this way, so it's linear. Ammonia is nitrogen combined with 3 hydrogen atoms. So this is actually not linear. While oxygen is bonded this way, so it's linear. The only non-linear molecule here is ammonia. So we go with ammonia. 100. Which of the following molecules is or are linear in shape? So let's find out which ones are linear. Nitrogen gas, nitrogen molecule would give us this. So this is linear because it's straight. Now CO2 is also linear. NH3, nitrogen bonded to 3 hydrogen atoms, is not linear. Then water is oxygen. Then the hydrogen bent this way, so this is not linear. It's actually bent or V-shaped. So the linear ones are nitrogen and carbon dioxide. So that's 1 and 2. It means the answer is B. Question 101. Which of the following oxide has a giant covalent structure? Okay, so giant covalent structures are formed by certain non-metals. So it's not necessarily by how many atoms you see here, okay, but by the structure that it forms. So we can eliminate sodium oxide and aluminium oxide because those ones will give us mostly ionic compounds. So it's either phosphorus oxide or silicon oxide. Now silicon oxide actually has a giant covalent structure because this is silica, and the structure of silica has a complex network. Not necessarily complex, but the network between the silicon and the oxygen is kind of complex. So it forms giant molecules of silicon oxide. While for phosphorus oxide, you can get the molecules are discrete. You can get them separate in smaller forms. But silicon oxide forms a network within itself or between itself, and so you at the end you get a very giant molecular structure. So the answer is C. Which of the following oxides is ionic? Okay, so ionic oxide would have to be a compound between oxygen and a metal. For it to be ionic, it means the difference in electronegativity must be large. So oxygen needs to bond with a metal for it to form an ionic compound. So that eliminates phosphorus oxide because phosphorus is a non-metal. It also eliminates sulfur dioxide because sulfur is a non-metal. Now magnesium oxide is an ionic compound. Aluminium oxide, surprisingly, is also an ionic compound. But I think here, the more appropriate answer to pick would be magnesium oxide because the difference in electronegativity between magnesium and oxygen is larger than between aluminium and oxygen. So magnesium and oxygen will give you is more likely to give you an ionic compound than aluminium and oxygen. Okay, so the answer is C. 103. Which of the following pairs of molecules form a hydrogen bond? Okay, so a hydrogen bond is formed between the partial positive hydrogen atom from one molecule and the partial negative electronegative element from another molecule. So an example would be oxygen, nitrogen, or fluorine. In this first one here, although we have nitrogen from one compound and oxygen from the other compound, the oxygen bonded to sulfur here is not partially negative because the covalent bond here is not polar. So because it doesn't have a charge, it cannot be attracted to the nitrogen in ammonia here. For this one, you have OH group, which actually forms a partial positive and negative between the O and H. The same thing is also applied to this second group of hydroxide. So it also has a partial positive and a partial negative. So it means that the partial negative oxygen here can be attracted to the partial positive hydrogen here. So you get a hydrogen bond between those two. For C is wrong because hydrogen molecule, the electrons are equally shared between the hydrogen atoms. So there's no charge there. there's no partial positive or negative charge. Same thing for this. In both cases, you have a non-polar covalent bond where there's no charge there. So the answer would be C. 104. Which of the following properties is not a characteristic of electrovalent compounds? Okay, so let's see. High vapor pressure. No, they don't have high vapor pressures. High vapor pressure is exhibited by compounds that are volatile or that easily turn into gases, such that the amount of gas you have compared to the liquid is higher, so that gives it a higher vapor pressure. So it's covalent compounds that usually have high vapor pressures because they are volatile. Now, ionic compounds or electrovalent compounds they can form crystalline solids. An example is salt, common salt. Salt is a crystalline solid at room temperature, and that's an ionic compound. Solubility in polar solvent. This is also true for electrovalent compounds because water is an example of a polar solvent, and they are soluble in water. They also have high melting and boiling point, so the odd one here is the high vapor pressure. 105. Which of the following properties of covalent compound is not correct? So now, covalent compounds, they have low melting points. They are mostly gaseous and volatile liquids, and they are not electrolytes. So the wrong one here is A. They don't have high boiling points. That's for ionic compounds. 106. Which of the following scientists formulated the law of conservation of mass? That would be Lavoisier. He was the one, Antoine Lavoisier was the one that came up with the law of conservation of mass. 107. Which of the following solids has a network structure? Okay, so a network structure would be diamond. So diamond is carbon atoms bonded together, and it gives you a kind of network structure between the carbon atoms. That's why the answer is diamond. For graphite, you have more of a layered structure there. So the carbon atoms are more arranged in layers. Why for diamond is very strong and very hard because the structure between the carbon atoms is very strong, and then it's a giant covalent compound because of the network between the carbon atoms. The answer is A. 108. Which of the following species does not contain a coordinate bond? Okay, so a coordinate bond, let's see. Yes, that would be tetrachloromethane, this one, because this one is formed from water and hydrogen plus. That's hydrozonium ion for D, is formed from water and hydrogen plus. So the lone pair in water is shared between water and the hydrogen plus ion. Ammonium is also formed from covalent bond. Okay, so you have a lone pair from ammonia plus hydrogen atom or hydrogen ion, and then they share the electron. Same thing for aluminium chloride here. The lone pair from one of the chlorine gets attracted to the second aluminium that needs a lone pair of electron. So the odd one here is tetrachloromethane. This is actually a covalent bond, not a coordinate covalent. It's purely covalent. Which of the following statements about dative bonding is not correct? So let's see. One atom must possess a lone pair of electron. That's true. There is sharing of electron. That is true. Each participating atom contributes one electron. Now this is not true. It's only one of the participating atom that brings the pair of electron, while the other one accepts. Now it can be formed between molecules. This is true. So the one that is false is C. 110. Which of the following statements is correct? Ionic compound in solution will conduct electricity. True. Hydrogen bond is formed between a metal and a non-metal. This is not true. It is formed between hydrogen and an electronegative, a highly electronegative element like oxygen, fluorine, and nitrogen. Covalent compounds consist of ions. This is not true. It is ionic compound that consists of ions. Covalent compounds would readily ionize in solution. This is not true because they don't conduct electricity. So the true statement here is A. Ionic compounds in solution will conduct electricity. Question 111. Which of the following substances does not have van der Waals forces? So the odd member out here is copper because copper is a metal. Metals, they have metallic bonds, not van der Waals forces. So graphite has van der Waals forces between the layers of the carbon structures. Iodine crystals, the molecules of iodine are held together by van der Waals. Neon is a noble gas, so the molecules of neon are held together by van der Waals. So copper is held together by a metallic bond. Question 112. Which of the following substances is non-polar? Okay, so a non-polar substance will be formed between two atoms that are the same, because if they are the same, then their electronegative values are the same. So the difference in the electronegative value will be 0, and then that tells us that the electrons between them are shared equally. So that would apply to bromine molecule here. So we have two bromine atoms coming together, and then they equally share the electron between them, and so you won't have a polar molecule here, or a polar substance. 113. Which of the following types of hybridization gives rise to a tetrahedral molecule? So hybridization refers to a combination of the s and p orbital when bonds are formed. So the answer here is actually sp3, but let me demonstrate why that is the case. Okay, so this is an s orbital, this is a p orbital. So what happens in hybridization is that the electron that is supposed to be here gets excited and goes into one of the boxes here. Okay, so you're going to have, let's say you already have two electrons here. The one that is here gets excited and comes here. So this time around you have 4 unpaired electrons. So one can become paired here. Let's say maybe one electron from hydrogen gets paired here, another from hydrogen gets paired here, another from hydrogen, another from hydrogen. And say this is carbon atom, so you can have CH4 here. Okay, so it means that the electrons in carbon arrange themselves in such a way that they created 4 spaces for the 4 hydrogen atoms to bond, to share their electrons, and so that's why this is tetrahedral. So the hybridization that allows that is sp3 hybridization. It's sp3 because you have 1 s orbital and 3 of the p subshell in p orbital. This is p orbital. So the 3 orbitals in p participated in the bonding, and then 1 s, that's sp3. So the answer is D. 114. Which of the particles indicated below represents an ion with a charge of 2+? So 2+ tells us that it lost 2 electrons. So if we examine the options here, in a neutral atom, the protons and the electrons are usually equal. They're usually the same. So, but in this case, there are 12 protons and 10 electrons. What this tells us is that this atom lost 2 electrons because the electrons would have been 12 in a neutral state, but then it lost 2 electrons and became 10. So this would be the answer. Losing 2 electrons would become 2+. This is not the answer. B is not the answer because the protons and electrons are equal. They are the same thing. So this is not an ion. In this case, there are 6 protons and 8 electrons. There are more electrons than protons. So it means that this atom gained 2 more electrons to become 8. Then for this, there are 16 protons and 18 electrons. More electrons than protons. So it gained 2 electrons. So both of these will give us -2 and -2, telling us that they gained the electrons. So the only +2 here is the first option. Okay, so that brings us to the end of the WASSCE questions on chemical bonding.